Hi, my name is Zhou. I'm from Australian University, China. This video is about my research over the summer I did as a part of the computational social science here at the University of Norway. My mentor is Dr. Paul Brenner and John O'Hare. We're working on the global migration model. There is no doubt that the human migration can affect the economies, the regional stability, and the lives of many different people. But now we don't have a powerful and accessible tool to understand why and where the migration occurred. Based on the economic theory, we introduced a global migration model, and our core method is to compare the expected earnings in destination minus the beta cost of the migration and earnings in origination. Well, the first question is, what are the earnings? Or to say how to quantify earnings. If we know the skill level of a migrant and the country name, we need a function to tell us how much the migrant will earn, both in destination and origination. That's why we construct the return to skill function, or to say RTS function. This is RTS function. Here we choose the three countries. The red one is United States, and the blue one is Mexico. The brown one is Syria. Based on the data income shares of each country by population quintile, each country's GDP and population size, we construct RTS function which captures the wages of every skill level within the country. Therefore, it can be used as a proxy for the distribution of a skill and wage. The second question is, what is the cost of migration? Which varies based on the relationship between origination and the destination. The factors that we have chosen to incorporate are geographic distance, the migration history between the origination and the destination, whether they share a language, and a measure of openness to immigrants and political freedoms in destination, which we summarize as political barriers. At first, the political barrier is composed of passport index and the freedom index. We replace the PB costs with the new visa index variable. We collect the latest data of visa issuances for more than 120 destination countries to track how difficult it is to obtain a permanent visa. The data resources are United Nations, Organization of American States, European Statistical Office, Organization for Economic Cooperation and Development, and then we normalize the data to construct a visa index. We then run the model with this index to validate the predictions against the actual data from 2015 to 2017. This is the relative difference of immigration between predictions and actual. The green part means that we overpredict the immigration into that country. The greener, the worse of the predictions. The purple part means that there are not so many people leave that country as we have predicted. If we use the absolute value of relative difference to evaluate the effect of each factor on the result of the model, we can have those bar charts. The first bar is the actual number of net migration. The second is the result if we only consider the earnings and regardless of the cost. It's easy to notice that this bar has the largest difference from the actual number. But if we take the cost into account, the predictions become much closer to the actual. Then we evaluate each factor of cost. We can tell the migration history is the most effective. In the future, we need to optimize the factors of cost. The linear model isn't enough to expand such a broad project. We need to add nonlinear variable into the cost and optimize the weights for each factor. Plus, we want to take the skill diffusion into account because as the model runs at high-skilled edges emigrant, knowledge will regenerate through a process of diffusion that occurs both among and between neighborhoods. This should allow us to capture a more accurate representation of human migration that takes into account the effects of brain drain and the limitations of skill regeneration as populations emigrate. At last, I would like to thank iSure program and the CRC for all the help provided. An additional thanks to John O'Hare and Dr. Paul Brenner for the resources and guidance invested into this project.